Welcome to another 3D printer review video. This is Sovol SV06 ACE. I already tested the SV06 on this channel and I wasn't sure that I want to accept this one, but from the Sovol they told me that it has significant improvements. I got this box for free, I can keep the product, but I'm not paid anything about this. This is a Klipper based bed slinger and with all those advantages which Klipper has, like network connectivity, input shaping and similar. They sent me some improvements in hardware. Z-axis is improved from 8 to 10 mm, but I already saw this improvement on SV06 Pro, for example. And also in specifications from their email, it has a Prusa MK4 ACE performance for only 1/3 of the price. If you're not familiar, the MK4 is open source and there are a lot of clones you can buy on AliExpress and similar. And basically this is based on that printer. Fully auto leveling and the Z offset setting, so we don't have to do this manually. It is able to move on 600 mm per second speed, but the recommended printing speed is between 250 and 300 mm per second. And it is able to do 20,000 mm per square second acceleration. And this is not typical for the bed slingers. Usually their limit is around 10,000, and this acceleration is typical for the Core XY printers. But it is able to print the Benchy in 14 minutes. It has 4.3-inch capacitive touchscreen and it has a very fast hot bed heating. And earlier I measured this, I already have the page on my website, but I can see from the website statistic that it is not a popular page and most of the users don't care about how fast is the bed heating, but I will measure it here and I will add to my website. Now I could compare it with the Prusa MK4, the old version. I don't have the S upgrade so far, but I don't think it's a good comparison because probably the MK4 will have a better print quality and the Sovol SV06 ACE will be faster. We will see that soon, but let's see what's in the box. The packaging is okay, everything is well protected in this black foam. This is the content of the package. We have the extruder and the mainboard box, which are already connected to the base. This is textured PI sheet and I can see a nozzle cleaner here. Oh, and a new linear motion. And this is the Z-axis with the gantry, and here I can also see that new linear motion, so they are not using the linear ball bearings anymore, but these metallic wheels on these rods. On Z-axis no change, they still use the linear ball bearings, but these are now 10 mm, not 8. Sample filament without spool, I hate this. Power supply unit, spool holder, tools and bolts for the assembling, and this is 4.3-inch touchscreen, and this is my wife's hobby. We are fighting for the space on the desk in the living room. It will be something like that or this. It's made from the paper. First step is connecting these two main parts together. And the good thing that we can install these bolts from the side. We don't have to do it from the bottom. The control box, I just have to slide it to its own place. And we have two USB plugs on the top. Installing the camera module. Installing the extruder with 3 bolts from the back side. Connecting the screen, and I hope it can be plugged only in one direction. I will try in this position. It should be in. Actually, we have the clear instructions for this. Installing the power supply unit, and this one has a fan, so it is not passive cooling like with the Prusa printers. Installing the spool holder, which rotates, and this is the filament runout sensor. And the last step in this installation is connecting the cables. And in my case, I finished the assembling in 1 hour with the camera work, but probably it can be done in ½ hours only. This is two-sided textured PI sheet, and it has some grooves, so we can easily place it in the same position. And there is some nozzle cleaner. Ah yes, I almost forgot. It's time to turn it on. And this time I will not forget to remove this foil from the camera. Probably this is first time booting. Start. Connecting to the network. Just quick check with my smartphone and it is connected and it works, only it is in Chinese. It will start with a self-check. It has 7 steps maybe, and we will see if it is completely automatic or it requires some manual adjustments. Self-check finished, it was completely automatic and I can click start to begin the printing. It's a Klipper screen, I can recognize it, only it has very unique design. Loading of the filament is prepared correctly. And there it is on the other side. Let's see what's prepared on the USB drive. 13-minute Benchy. It's cleaning a nozzle and it has some purge material on the back of the build plate. Nozzle cleaning, and hopefully it will start soon, or maybe it will do the auto leveling first. Yes, it's doing the auto leveling first. And it started the printing, and this is the brim currently. It speed up now significantly after the third layer, and also I can hear the fan. I will measure the noise soon, and I can see this is quite optimized Benchy for faster printing. Very minimal infill. The noise from half-meter distance, approximately 63-64 decibels. That's quite loud for the bed slinger, but it's fast. It is always fun to watch bed slingers moving so fast. And this is that a little bit more than 13-minute Benchy. Bed adhesion check. It's good. I have to wait until the bed cools down, but the quality is quite good. The bed cooled down a little bit. Let's try to remove the Benchy. Oh, perfect. I would never tell that this is 13-minute Benchy on the bed slinger. The quality is surprisingly good, but it is time to prepare the slicer and slice my own G-code. I checked the content of the USB drive which arrived with the printer, and I find the profiles for the Orca slicer. All I have to do is to copy these files to the profiles folder of the software, and then I have this printer in the list. I can select it and I can switch to this printer. But the bad news is that I have only one profile, at least in my version, and this D6 dice calibration cube will be the first object. Now we have the thumbnail image. Print. And it starts with the printing. First layer looks correct. The progress is good. This is D6 dice, something like calibration cube, but with the X and Y spots on the side. It's finished. Oh, perfect. The bed cooled down already. The surface quality is good. There is no ghosting. In X direction it has correct size. In Y direction it's a little bit smaller. And in the Z direction a little bit bigger, but acceptable. I decided to check the maximal flow rate with the sample filaments, and I'm using this web tool which is based on the CNC kitchen method. In first attempt I have this error, and then I had to add this line to the printer configuration file. And after this it started correctly. So here you can see the small bulbs extrusions. And now I have to measure them. And I measure each of them, and you will see them soon in the graph. And this is the result. And if we take the 5% under extrusion as a still acceptable by many experts, in that case the 24 approximately on 220 degrees Celsius is the maximal flow rate. On 240 degrees Celsius, even on the 26 cubic millimeters per second is still on the line. But to be honest, I don't like to use this method because when it starts to reduce the flow, it will significantly reduce the layer adhesion. So for me, on 220 degrees Celsius, 18 is the maximum, and on 240, 22 with this sample filament. The printing starts with cleaning of the nozzle, and then it do the auto leveling, but only on area where the printing will be located, purge line, and it starts with the printing. The start is good. Now it's printing at the full speed with all fans on. And this is what I can see from my laptop over the user interface. Printing is at 70%. It's finished and I can see a small brim, or maybe it's elephant foot, but let's see if I can free it. Not with one hand. I just move it with two hands and now it's rotating freely. Only I forgot to disable this small brim outside. In Slicer I noticed the scrot is enabled with the zero distance, which is quite annoying because if I wanted to touch the object, I would use the brim. It's a D12 dice, and on a halfway I will cut the filament to test the filament runout sensor, and then I will replace it with this filament. Filament cut. The sensor is triggered. And from now on I just follow the instructions on the screen, and it purges a little bit filament and continue, resume, and it continues with the printing. There is some oozing, but I think I can remove that easily. It will be an interesting one, and I think during this filament change the extruder should wait here. In that case I could easily remove that oozing from the nozzle. Let's analyze the object. Okay, that's the skirt. That oozing fall off immediately, I don't have to remove it. And this looks really nice. So this filament radar sensor and the software works correctly. My wife ordered a small storage box, but this small means that it will use the whole build surface, at least in y-axis. And the first layer looks good. But I also noticed that the object is not completely in the center. This infill printing looks really fast for the bed slinger. Oh, I wasn't here, and definitely I have to slow it down. Oh, and now I can see I have to stop the printing because it has a layer shift. Layer shift, and I will try to reprint this without any change, only I have to slow it down. Just to be sure that the problem is in the speed, I am reprinting the same G-code, only I will slow it down manually. And now I reduce the speed to 60%, and I hope it will be okay because it's midnight here and I have to go to sleep, so it will be finished overnight. I also noticed the default temperature for the PLA filaments is 210 degrees Celsius, which I think is too low, so I raise it to 220 degrees Celsius. Good morning, and this time it was finished correctly. Right, it's already removed. Looks nice, but I think I have to repeat the flow rate test with this filament too, on 210 degrees. And this is a repeated flow test on 210 and 230 degrees Celsius, this second row. And I measured each object. And this is the result, but I will show you in the graph too. This is good filament, pity that this brand doesn't exist anymore. On every measure point the flow rate was near 100%, so the problem is not in the maximal flow, maybe it's the maximal acceleration. 20,000 is maybe too much for the bed slinger, but that layer shift was along the x-axis. It will stay a mystery until the comments will solve it. It's time to compare it with Mark IV. The printing time on the Sovol printer will be 54 minutes, and with exactly same settings on Prusa Mark IV, 1 hour and 56 minutes. And side by side two printings, and don't forget this is still Mark IV, not the S version so far. The Sovol finished earlier, and now I'm marking this turtle. And again, this stupid skirt, I forgot to change the distance from 0 to some bigger number, because I don't want to use the brim. I need a skirt with some distance. Now let's compare the quality. At the first look they are very similar. Of course this is very easy for printing. On Prusa I use the smooth sheet, on Sovol the textured one. And only one thing I noticed here, for example, the head don't go completely down with the Sovol, and the reason for this is that skirt with 0mm distance. So this is really quite annoying. I will clean it, but this is one of the things I noticed. And the other is, I'm not sure if it will be visible on the camera too, that the bridging here is nicer a little bit on the Prusa printer compared to the Sovol. But the difference is very minimal, and don't forget that this was printed 2 times faster. Now I want to try to create some time-lapse, but the camera is pointing to the window and I'm rotating the printer because the window in the background is not good for the nice time-lapse. This will be the file, and in the settings I'm enabling parking the tool head, and this is the only change I made here. And I can start the printing, and I confirm that I want to create the time-lapse too. And this is how it works. After every finished layer, the head moved to a side so the picture can be created, but unfortunately this camera position is not the best for these time lapses. The printing is finished, but there are a lot of oozing marks. I don't really like this time-lapse method. But of course this is cleanable, and now I have to go to the time-lapse menu point and I can download this recorded video. And this is the final result. Not the best position for the object when the camera is on the side. Later I will show you a little bit better position and how it looks like. I tried to connect this Logitech web camera, but it was not recognized. With SV08 for example, it worked immediately after the plug, but here we are stuck with this stock camera. And this is the better position, only I started the printing with the window in the background, so I rotated it later, but yes, it looks much better in this position. I also noticed on this material I had a less oozing compared to this one. Of course I cleaned it already, but interesting differences. I still want to do some bigger printings on the maximal speed to see if that layer shift will appear again. I think this is too fast for this printer. temperatures of the stepper motors are okay because I can touch them. This means they are below 60 degrees Celsius. As you can see, the stepper motors are colder than the hotbed. Printing is fast, but it looks okay so far. It's finished exactly now, and I'm using here the Prusa MK3 filament. It was finished correctly. With this attempt, not only the layer shift was the problem, but these small points on the material. So I will reprint now using this Prusa MK3, and I will use the same speed. We will see if I can reproduce this error. Just in case if I forgot to mention it, still perfect first layer. It is very close to that critical point, and this still looks nice so far. And only one thing actually I changed, I raised the print temperature from 210 to 220 degrees Celsius. The temperature of the X stepper motor is around 50 degrees Celsius, which is fine, there is no overheating. And it was finished correctly, and it has super nice surface too. Now I'm definitely confused. This was my first attempt with this layer shift, but printing was on 210 degrees Celsius. Then here I reduced the speed to 60%, but I also increased the temperature to 220, and it was finished correctly, only I have these unequal surfaces. And then I changed the filament, and this was printed on full speed, but also on 220 degrees Celsius, and it was finished nicely. So definitely I'm not sure what was the problem here. And now quick conclusions for the end, but first I have to turn it off because we don't have a quiet standby position. Much better. Before my opinion about this printer, one more time to clear one important thing. So I got this product for free, I don't have to send it back, but I'm not paid anything about this, and I don't have any kind of the contract, so I have free hand to talk about it. There is very interesting trend between the 3D printing YouTubers. If you don't know what I'm talking about, watch the YJK 3D video about this. I place a link down in the description to his video. And yes, I also got some kind of conditions from the FLSAM for their new Delta printers. That's why I didn't accept that review video. But for the V400, which I published a few weeks ago, I don't have any kind of contract or conditions. And also I mentioned these things at the end of that video. Okay, now about this printer. First I will talk what I like about it. It is a good bed slinger actually. I'm not sure how bed slingers have the future, but I think they still have the market. I can see the A1 from the Bambu Lab is much more popular, but this is much cheaper and based on Prusa MK4. Not exactly the same printer, of course, but it has fully automatic calibration. We don't have to do anything manually. It is Klipper based, fast, and still have the good quality. I compared the quality with the Prusa MK4 and they are very similar. What I don't like, now important to mention that I got this unit 1 month ago, very early unit, but as I mentioned I can present the machine as it is now. Not completely finished, but small things. Let me go through them. I don't like that skirt, the default distance is 0 mm. It is so annoying. If I want to use the brim, I will use brim, but skirt must have some distance in different settings. Printing is not completely in the center, and with Klipper this is very easy to fix, modifying in the printer configuration file. I think the posing should be in the front of the bed, not in the back side, because in that case, if there is some oozing, with the tweezers we can very easily remove that from the nozzle. And as I mentioned, this is a very early unit, and I still have only one profile for the PLA 0.4 mm nozzle. And I'm not sure, maybe it is too fast actually, especially that acceleration. 20,000 millimeters per square second sounds too much, and I still have that mysterious layer shift. And if you have idea what resulted this layer shift, then please inform me, because I'm confused. I couldn't reproduce this error. And also would like to see that standby position to be completely quiet. That's why I had to turn it off during this recording, because I can still hear some fans inside. I mean, I can see that the printer manufacturers don't really care about this, but this is important for us. I mean, it can be always in a standby position, enabled but quiet, and if I need it, just send the printing and it can start with the print. So this is my honest opinion about this printer, and I always try to show you the facts and my journey it's assembling and with these first prints. If you have some other experience, then write me down in the comment section a few lines. Thank you for watching and happy printing.